So let's talk about rectifier tubes and input capacitance. And as you know, rectifier tubes, they do not like a big input capacitance. So for example, so here we have RCA, new old stock 5AR4s, but if I had here a Softec 5AR4 or any other new production 5AR4s, the limit for input capacitance is pretty much 40 microfarads. And if I have something like a 5R4GY, then you would want to limit the input capacitance to 20 microfarads. And if you have mercury vapor tube, I would recommend to use it with choke input only. So there's no capacitors in the input supply, or if you absolutely must for the small mercury tubes like the 83, you can get away with a couple, maybe like 5, even 10 microfarads if you don't pull too much current. But if you have the 866, the big ones, for those ones, only a tuning cap is allowed, maybe like 2-3 microfarad at most. But really, the tube will be happy if you use choke input. And here, however, I will show you guys something that will blow the mind of many, is that in this Quicksilver amplifier, there's a pair of 5AR4 tubes, and they are feeding 330 microfarads of input capacitance. And holy smokes, yes, that's the response for that, because if these were, well, so when you double up the tubes, you can double up the input capacitance, but even then, you would not go bigger than 80 microfarads, and this is 4 times the upper limit. So that's totally nuts. And if I would have like Softec tubes here, they would blow up within the first week. They wouldn't even last a week in the amp. And other new old stock tubes, probably they might last maybe a month, but not more than a month. That's it. And they will probably not blow up like blowing up, just they will weaken very fast. And the reason for that is because the bigger the input capacitance, the more current it pulls from the rectifier. So it means that the cathode of the rectifier tube is stressed, so there's tons of electrons that have to move away from the cathode at really high speed, because there's tremendous electromotive force that is pulling, that there's tremendous capacitance that's pulling off those electrons, and it's tripping the cathode. So each time you turn your amp on and off, that's when there's the biggest pull, because that's when your cap is empty and it has to charge from empty. And when that happens, then you have gigantic peak input currents. Like in this size, we have something like 20 amps current draw. And if we have a 40 microfarad input capacitance, then we have something like 8 amp current draw. If you have a choke input supply, then it's like an amp or less when you turn on the tube. So and the bigger the current draw, the more you deplete your cathode. Of course, you want bigger current, as big current draw as possible, because the bigger the draw, then the faster the cap can replenish, and that's good for the sound. However, there's always comes a balance when it's best for the sound and it's still okay for the tube. But these tubes were made in a way so the oxide coating on their cathodes is so thick that they can handle this crazy operation, not just for maybe a few hours like a Softec tube would do, but guess what? These tubes have been here in this operation for almost 20 years. 20 years. Isn't that crazy? So yes, that's why the NOS tubes are often legendary, because they were just often made to entirely different specifications than what tube manufacturers are building their tubes now. And so eventually what I did with this amplifier is that even though they can handle this monstrous current draw, but that's a tremendous pull on the transformer because it's pulling amazing current at each turn on and at each duty cycle. It makes more transformer noise. However, because Mike, he makes excellent power transformers, there's no noise issue related to that. But still, what I did is I placed a small resistor and an input capacitor. So there's a, what did I do? Here it is. You can see that bugger over there. So it's 56 microfarad, 500 volts. So basically I cut down the input capacitance 5 times. So when the rectifier tubes are pulling the current from your power transformer, it goes first, this cap is charging up. So basically that's half of it, 27 microfarad per rectifier tube, which is well within the specification. So now if Alan wanted to use other rectifier tubes than NOS GEs or the American tubes or Malar tubes, they can also take the beating. He can use any rectifier tube he wants and do some rectifier rolling. And here I place the little resistor there, a 5 watt, and then it goes to, that's the underside of those big caps there. This guy, the big cap. So that's what it is. So that's how input capacitance works for rectifier tubes, and there are some rectifiers which can handle monstrous input capacitances. But I want to let you know that do not think of that there's a certain tube type like 5AR4 that can handle the monstrous current. No, because within the 5AR4, like RCA, GE, and Mullard can handle that sort of capacitances, but new production tubes will keel over very, very fast. And thank you for tuning in. I hope this was a little bit helpful. So when you build or redesign your power supply, then you will have more choices and options for you. And by the way, my other reason to put that smaller cap in there, it also improved the sound quality because there's just one more step of input filtering. So how the Quicksilver's power supply works is that normally the rectifier tubes feed your first section, the 330 microfarad, and that feeds the B plus of the power tubes, of course, through the output transformer. And it's center tapped, and each of the taps feed each of these tubes. And the center tap is connected here to the capacitor. So, but if you have only a single capacitor, that doesn't do too much filtering, so there's quite a bit of ripple riding. And of course, because it's a push-pull amp, the ripple is the same on top of both of the tubes, so it cancels out. But I talk about that later, that it's still an issue, and why is that an issue, and why I want to keep that ripple as low as possible. And after that, because that's enough for the output stage, but it's not enough for the input stage, so what Mike does is he has a small choke there, and then a second capacitor for the power supply. So it means that these fellows are getting choke filtered B+. So that's really fantastic. And after the choke, there's another 330 microfarad huge capacitor. And as you see, it's 500 volts rated. It ticks around 450 volts or so. And let's see what we have here. So because of the choke filtering, these guys, the input tube and the phase splitter, they are really happy with what they are doing. They have nice quiet supply, but by adding that extra pi filter there, I'm making it quieter for the power tubes as well. And of course, because I'm adding here a resistor instead of a choke, then I'm slowing down the power supply a bit, so that's a negative. But still, because it's getting quieter, the ripple is quieter, the low level performance, the low signal performance is increased a little bit. And overall there's a benefit in the sound. However, if we wanted to make this amp even better sounding, much more faster, much more dynamic, then instead of that resistor, just take that out and put another choke like that right here, so that we get this C1 first capacitor choke, second cap choke, and then third cap feeding the input stage. So thank you for tuning in. I hope this was helpful. Bye bye.